Fascinating Frontiers, episode 121 for July 4th, 2026. Let's look at what's new across the frontiers of space and science. A robotic spacecraft just launched to nudge a long-running NASA observatory back into a stable orbit. The Pegasus XL lifted off from Kwajalein Atoll, carrying Katalyst Space's Link robotic servicer on the SWIFT Reboost Mission. Stargazer released the rocket near 166 degrees west, 7.5 degrees north at roughly 0836 UTC on July 3. Link will rendezvous with NASA's Neil Gehrels Swift Observatory and perform a controlled boost to raise its orbit. Communications with the servicer have already been established after separation. The flight may mark the final use of the Pegasus rocket family. Teams will next test Link's proximity operations and docking hardware before the reboost maneuver. Two privately built spacecraft performed a controlled rendezvous and intercept under the Victus-Hayes mission. The exercise demonstrated rapid response orbital maneuvering for the U.S. Space Force. One vehicle approached and passed the other at close range while ground teams tracked both objects. The data will inform future tactics for on-orbit inspection and servicing. Now we turn from active orbital operations to how we discover distant worlds. Archived data from NASA's Transiting Exoplanet Survey satellite revealed a Jupiter-mass world whose gravity briefly magnified light from a background star. The event marks the spacecraft's initial use of microlensing rather than its usual transit method. The planet, designated HD 126105b in related catalog entries, orbits at 1.36 AU from its K-type host. The technique opens a new search channel for worlds that do not cross their stars from TSES's line of sight. Follow-up observations from ground telescopes are planned to refine the mass and orbit. If the sun were replaced by a bowling ball on a vast frozen lake, a passing star would bend the surrounding ice just enough to focus light from a distant object into a brief, bright flash visible from shore. That flash is gravitational microlensing. The foreground mass warps space-time so that light rays from a background source converge toward the observer for a few hours or days. In the TESE's case, the lens was a Jupiter-mass planet roughly 1.4 AU from its host star, and the brightening lasted long enough for the satellite's cameras to record it in archived frames. The probability of catching such an alignment is tiny, roughly 1 in a million for any given background star, yet the survey's wide field and repeated visits made the first detection possible. The same physics that lets us weigh planets we cannot see also lets us measure the mass of free-floating worlds and even rogue black holes, provided the alignment is caught. The open question is whether the current archive already contains dozens more events that simply have not been searched with the right algorithms. Astronomers have identified a system in which 6 supermassive galaxies are simultaneously merging. The structure was found in deep imaging and spectroscopic data from several large telescopes. Each galaxy hosts a central black hole that is actively accreting during the encounter. The event offers a rare laboratory for studying how the most massive galaxies assembled. Additional multi-wavelength observations are underway to measure gas inflows and star formation rates across the merging system. The James Webb Space Telescope has discovered M1149-BSG-Z5, a barred spiral galaxy already in place when the universe was less than 1.2 billion years old. The bar and spiral arms appear well developed despite the early epoch. The detection challenges models that predict slower formation of such ordered structures. Follow-up spectroscopy will measure the galaxy's stellar mass and star formation history. Galaxy SDSS J110546.07 plus 145202.4 has remained bright at radio wavelengths for several years after an initial outburst. The emission is thought to arise from material still interacting with the central black hole long after the original disruption event. The source is the first known example of such a prolonged radio transient at a galactic nucleus. Continued monitoring will test whether similar flares have been missed in earlier surveys. Extreme winds on several ultra-hot Jupiters have been mapped for the first time, revealing the presence of planetary magnetic fields. The measurements come from high-resolution spectroscopy of iron and other metals in the dayside atmospheres. Field strengths appear comparable to those inferred for Jupiter itself. The discovery supplies the first direct evidence that these close-in gas giants generate internal dynamos. Additional targets are now being observed to test how field strength varies with orbital distance and stellar irradiation. JWST observations have identified sodium chloride clouds in the atmosphere of the well-studied world, nicknamed the Pink Planet. The clouds form at altitudes where temperatures allow salt vapor to condense. This marks the first clear detection of chloride-bearing clouds on any exoplanet. The finding helps refine models of cloud chemistry under intense stellar heating. Further spectra are expected to map how the cloud deck changes with longitude. A gas giant has been found orbiting the white dwarf remnant of a sun-like star that previously expanded into a red giant. The planet's orbit lies far enough out that it avoided engulfment during the star's expansion. Its survival supplies a direct analog for the possible fate of Jupiter once the Sun leaves the main sequence. Additional systems are being searched to determine how common such survivors may be. The two planets reached closest approach at 1 a.m. Eastern Daylight Time on July 4. By roughly 4:30 a.m. local daylight time, both worlds stood about 16 degrees above the eastern horizon. Mars appeared as a bright red point, while Uranus required binoculars or a small telescope to resolve. The conjunction offers skywatchers a convenient reference for locating the ice giant. Observers in the Americas and Europe had the best viewing geometry. A new Hubble portrait shows a bright red emission nebula threaded with clusters of blue and white stars. The image highlights regions where intense ultraviolet radiation from the hottest stars is ionizing surrounding hydrogen gas. The nebula lies several thousand light-years from Earth in the Milky Way plane. The data will help calibrate models of feedback between massive stars and their natal clouds. A stacked exposure totaling just over 3 hours on a C-STAR S50 smart telescope produced a high-resolution view of the Cocoon Nebula. The image reveals the nebula's intricate dust lanes and embedded star-forming regions. Processing was completed in standard photo editing software. Such compact instruments are enabling more backyard astronomers to contribute scientifically useful data. The telescope released a set of images highlighting red, white, and blue features across the solar system and beyond. The release coincides with the national milestone and showcases ongoing science operations. Hubble continues to deliver data more than 3 decades after launch. Sophie Adenauer captured a striking green auroral ribbon from the International Space Station during the Epsilon mission. The time-lapse covers more than an hour of orbital night and shows the curtain shifting and brightening. The footage was recorded on day 139 of the mission. It provides a high-resolution record of auroral dynamics at the altitude of the station. The astronaut returned to her Massachusetts hometown after her recent spaceflight and met former classmates. The visit highlighted local pride in her contributions to NASA's Commercial Crew program. Williams has flown on multiple missions to the International Space Station. Keep an eye on the next round of JWST spectra that could map how those salt clouds shift across WASP 39b. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen: Environmental Intelligence, the Environment and Climate Policy Brief for Canada. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
drifting softly through